In this last word problem, we are looking to enclose an area. So it says that we have a stonemason has enough stones to enclose a rectangular patio with 60 feet of perimeter. So this is what we're trying to enclose, and we have 60 feet to work with. Assuming that the attached house forms one side of the rectangle, so you don't have to put a wall there. What is the maximum area that the mason can enclose? What should the dimensions of the patio be in order to yield this area? So let's give ourselves a little bit of a visual. That's what we're enclosing. It makes a rectangle, but we don't have to put stones here. We just want to put it around here and here. So if we say that this is X and this is X, because they would be the same, we're making a rectangle, you have 60 feet total. So this piece is going to be 60 feet minus both of those two, so minus 2x. All right, so together that whole thing makes 60. So what we are trying to do is we are trying to maximize the area, which means we need an area equation. So area on a rectangle is a length times a width. So our area is an x times a 60 minus 2x. And then if we distribute that through, we get a 60x minus 2x squared. Let's put the order a little bit kind of a standard form. So negative 2x squared plus 60x. Okay, so we are trying to maximize the area, which means we're trying to find the vertex of this quadratic. So to find the vertex, we're going to find the x value, which is negative b divided by 2a, which is going to be a negative 60 divided by 2 times negative 2. So negative 60 divided by negative 4 turns out to be 15. All right. So to figure out the rest of this, so we need the dimensions on this. So there's two parts of this: is what is the maximum area, and then what are our dimensions. So you could do this a couple different ways. Is you already have one of the sides. You could plug in 15 into this, get your dimensions, and then you can find your area. Or you could just plug it back into the equation. Does not matter. It's going to get you the exact same result. So I'll just keep using the formula. So negative 2 times 15 squared plus 60 times 15. So if you plug that into the calculator, you're going to get a maximum area of 450. And then to figure out this dimension here, we're going to do 60 minus 2 times 15. So that's going to be 60 minus 30. Okay, so our maximum area is 450 square feet. And then our dimensions are 15 feet by 30 feet. So here's what I would do just to verify that everything works. I would do, I don't know where 480 came from, 450. So that was perfect because I would multiply this together, and 15 times 30 would make 450, not 480. But I would double check that me plugging it into this equation gets me the same result as me multiplying our dimensions together and gets 450. So everything lines up, everything looks good. And that is the last of our word problems involving quadratics, where we are trying to find a maximum or a minimum.